All right, so video on more Google Sheets, yay. Now we're going to get pretty graphs. So this video is all about graphing. And the graph we're going to make, hopefully, or graphs, I should say, we're going to make are hopefully going to show you why we use this. I mean, doing data calculations is fine, but part of the magic of sheets, or part of the magic of spreadsheets in general, is that you can take data and make it visual, which is nice because it's easier for our brains to visualize if we have something in front of us than if we have to do it abstractly. Okay, not that I'm saying it's impossible, but it's a thing a lot of people struggle with. Okay, so we like to make graphs, make it easier to visualize data. So I have here some data, and you say, cool, we have data. This data is actually from my physics class, so this is not from physical science. But if you look at this data, it's not too dissimilar from what we were doing in class. I have my 4 types of running, right? My first trial, which is in this case, this is the slow walk. Second one was fast running. Third was accelerating slow to fast. Fourth was kind of the opposite, fast to slow acceleration. Okay. I also included this column here. What this is this is where the person in theory was standing who was recording the time. Okay. It's not perfect, but it's a good approximation. Okay. So in theory, each person was standing about 2.67 meters away from the other person. Okay, your class might be different. In this case, it was 2.67. Okay, so in theory, a person is lined up as the runner goes by every 2.67 meters, starting at 0. Right, we have a person who's at the first mark all the way down to the end. Right, the person who's right at the end of the race. Okay, so hopefully that makes sense. And what I'm going to do now is I'm going to graph. Make several graphs, I should say. And we have options. Okay, again, name of the game here is you got lots of ways to do this. I'll show you a couple. Okay, and there's many more you could do, but these are the 2 that I think are most logical. To graph in Sheets, the first thing we got to do is pick data to graph. What a surprise. So I'm going to pick to start my times. And let's start with the slow time, right? That's my first one. I'm going to click on A. Everything in A, including the title. Okay, this will save me time, so make sure you do it. Everything in A. And then I'm going to hold Control. Control is telling the computer, hey, hold on to those numbers. And then I'm going to click on my displacement. Okay, so now I've let go. You see I'm not holding it. And I have both of these selected. Okay, once you have them selected, and if you make a mistake, oh no, I forgot to click Control, what do I do? Well, you just do it again, right? A, hold Control, in this case E. Okay, and then I go to Insert, and I insert a chart. Okay. Now the chart, depending on how Google is feeling that day, it might give you the chart you're looking for. It might give you the chart you're not looking for. Okay. And you're like, what do you mean by that? This is a scatter plot, and this is what you should pretty much, without exception in this class, always go to. Okay. If it doesn't, if you got this, is this horrible? It's not horrible. It's just not as good as, say, this. And if you're going why, you'll notice this gives the individual data points, which is nice. Okay, the line chart kind of ignores that, and it's not like it's abysmal. It's not like this is the worst thing in the world, but this is better for us because we can see each individual data point. Okay, you'll notice my graph looks like this. It has like a line sort of kind of, like a little bit of a waviness to it. Okay, if I look at my graph, I can click and move it around. If I hover, you can see a little hand thing. I can click it, and move it around here. Okay. Do I like this graph? Well, let's see. My y-axis is displacement. My x-axis is, let me see if I can scroll down so you can see a little better. My x-axis is time. Okay. And this is looking pretty good so far. Okay. In a graph, if you start changing things around, right, it'll make the graph look different. What a surprise, right? This is not that surprising, hopefully. But in your options I'll just go through these quickly. In your options for how to change the graph, right, the most important thing is what type. Under setup, please make sure it's a scatter, okay? If your graph is, I don't know, this, well, that's not very useful. Okay, it's not useful for this, I should say. It might be useful for something else, but not for this class, right? If you get a histogram, again, this is not a helpful thing right here. Histograms are very useful, but not for what we did here. Okay, a column chart, again, not helpful at all. So please, please, please make sure it's a scatter plot. Okay, go to Customize. There's many things you can change here. Okay, if you're like, I really want to have a red background, I guess I wouldn't do that. That doesn't look very nice. It kind of gives me the heebie-jeebies, right? You're like, I really like purple. Well, great. I mean, again, it's this is like the last thing you do. We don't spend hours on what color it is, right? What you do want to make sure you spend time on are the axes titles. So the title of the graph and the title of the axes. The title right now is displacement versus first trial. It's not a horrible name, but it's not quite clear. I might call this something like, let's say, slow walk velocity, or slow walk displacement over time. Something like that, okay? You'll see how velocity would be an acceptable name, right? We'll get into that in a minute, okay? Got options there. All right, you can change then from chart title to the, for example, the horizontal axis title. That's the Y, or I'm sorry, that's the X, sorry. Right now it's what? First trial slow in seconds. I might just say like, I might change this to time in seconds. I might say time since start, right? You got options. Time usually you can just leave as time, lowercase s for seconds, okay? And you'll notice that when I do that, it updates down there. Okay. I can also double click. If I want to save myself time, instead of having to find it over here, I can just double click and edit things. It automatically does it for me, which is pretty nice. Displacement in meters, perfectly reasonable. Okay, perfectly good name for a axis title. Don't forget, it's got to have units. There are some exceptions to that, but they're pretty rare. I would just say it should have units. And if you get to something that doesn't have units, well, then that's the exception. We'll get to that when we get to that. Okay, it'll make sense. It's not like it's a you couldn't have figured it out type thing, okay? All right. Oh, I clicked the button apparently. I shouldn't have done that. Hang on. Uh-oh. Well, let's see. Can I go back? Can I go back, please? There we go. Okay, good. I got scared for a second. All right. Anyway, so this graph, yay. What sense do I make of it? Well, right now it looks like this. And you say, I don't know. It's all right, I guess. Let's make it look prettier, or rather, let's get some more information. I go to series now. Series is what's graphed, the thing that is actually plotted on the graph, okay? And again, I could change things. If I don't like the color blue, I could change it to red. I could change it to whatever. This might be useful in a couple minutes, okay? But for right now, it's whatever. Blue is probably fine, but I'll leave it red, because why not? We get on here, and this is where Google Sheets earns its pay. Okay, so I have options. Data labels, that tells me what it is. Error bars is a little bit above the scope of this class. I'm not saying it's too hard, but it's not something we use in this class. Okay, what we use though is trend line. And a trend line is me telling the computer, hey, can you find a way to like connect these dots basically? All right, and I know it sounds kind of weird, like why would we do it? Because we can do math with this, and math is very good. Notice it says type. We got options. Okay, exponential, we got a polynomial, we got a logarithm, right? We got lots of options. Generally speaking, you jump to linear. And if this looks pretty good, if you're like, hey, you know what? It's not perfect, but it's got a pretty good match, it means it's probably linear. You're probably saying right now, what do you mean by linear? Well, what I mean is that the relationship between the x-axis and the y-axis would appear to be a line, would appear to be a linear function. So if I increase x by 5, y should increase by the same amount every time x increases by 5. Okay, it's a linear function. If that's confusing to you, if you're like, I have no idea what you're talking about, it means you should come in and talk to me about math. Okay, I got to make sure your algebra skills, or in this case, basic graph interpretation skills, are up to snuff, because you need to know this stuff. Okay, it's part of high school is making sure you take the stuff you learn from other classes and apply it. In this case, we're applying slope. We're applying a linear function and understanding what it means. Okay. You have an equation. You say, where's the equation? I don't see it. Well, where it says label, I can click there and say, hey, tell me the equation. And what this then tells me right here is the equation. In this case, it says the equation is 1.34x plus, and that this is a bit annoying, plus negative 2.43, aka minus 2.43. Okay. This is a linear equation. Y equals mx plus b. Okay, the y is what's going to be plotted against the y-axis. The m is that 1.34. Okay, The x, of course, is the x value. That's on your x-axis. And then the b value, your y-intercept, is this number over here, negative 2.43. Okay, hope that's making sense. Now you might say to yourself, cool, who cares? Well, the slope of this. Slope is the change in y divided by the change in x, right? So what is y? It's meters. It's displacement. So a change in meters divided by a change in time is the slope. Hey, what unit is that? What is m divided by? It's velocity. The slope of this equation, that 1.34, is the slope and therefore the velocity. Okay, that is the velocity. And you'll notice the velocity does not really appear to change. You might notice there's times it kind of goes a little bit lower, right? It's not a perfect line, but it's pretty darn close. As a matter of fact, we can tell the computer, hey, how close is it? Is this a good line? If I click this show r squared button, r squared, to make it easy, is basically how well does that equation fit the data. That's basically what it is. Now, a stats person will look at what I just said and say that's not 100% true, but it's like 97% true, so it works for us. Okay, it's a pretty good description. I don't think anybody would say it's an incorrect way to view it. It's not the full picture, though. Okay, so hey, that's a pretty good r squared. If you're saying, what's a good r squared, Carol? A 1 is perfection. 1 is it's exactly. 0 is there's no relationship at all. This is crazy. 0.989 is pretty darn good. That's pretty close to 1. That's a pretty good answer. I'd say that is a good function. Yay. Okay. Cool, I got that graph. So then what I can do is maybe make a second graph. Okay, and I have options. I could take this, for example, FYI, and I could say, hey, computer, move it to its own sheet. So now I have chart 1 here, and you'll notice this on its own sheet, nice and zoomed in. It's easier to read. It takes up a nice amount of space, so I can kind of look at this a little more carefully, right? It's a good option. You don't have to do it, but it doesn't hurt, okay? I can make more, right? So I could go back to sheet 1, and I can say this time let's take maybe the fast, and let's graph that against displacement again. So same thing, click and drag, or click and hold control, and then I go in and click insert, and I say a chart, and here is my data. And you'll notice this one looks a little bit different, okay? But we could do the same thing to it here, right? We could go in and give it a trend line. We can make sure we give it good names, all that fun stuff. What I'm gonna do now is I'm gonna stop this video, and then I think I'm gonna pick it right up in the next video, if that makes sense, to keep these relatively short, okay? So we'll pick it up there.